With Flash, the value proposition isn't about the capacity so much as it's about the performance. Consequently, what we have to do is educate the sellers and educate the clients on building that value proposition based primarily on the performance characteristics. You could scale out to lots of capacity, but the fact is that this isn't a solution for your general purpose gigantic amounts of data for most economic value. So what we'll see instead is that there's a greater focus on what's the productivity of your users, what's the productivity of your business, what does it look like if we took this application which may be making you money and scaled it out significantly. And that's where we develop the value of Flash. You've got data and you need to store that, and that's definitely a requirement, but it's much more about the performance characteristics that ultimately drive the business value. I'm actually a big fan of tape. I think the power consumption of tape in an archive state is great, and that's probably the best long-term solution for archive. But there are some people who, for whatever reason, want an all-silicon data center and are allergic to the technology idea of tape. And those extremely low write cycle flash actually could give you a low enough cost that it could be valid, but I'm a big fan of tape for archive. But I'll say that if you charge things gently enough, if you're very careful with how you work with the physical programming voltage of the flash, even that extremely low reliability flash, the TLC and the very low-end consumer stuff, could be made to retain data for a fairly long amount of time. That's actually one of the tricks that we use when going from standard MLC to enterprise MLC. We adjust the retention period by programming the data at different rates within the chip. There are lots of mitigations for any weakness in technology, so Flash is intrinsically limited by the number of program erase cycles. We have very effective solutions that involve putting a little bit of extra Flash as a reserved capacity so that you can swap in if you wear something out. And then of course we distribute writes across every bit of Flash in for example, the Flash systems. So both of those allow us to achieve these kinds of enterprise lifespans, which many of our clients are requiring. First of all, in regards to the general concept, what you're describing is skew. So that means that essentially there are different pieces of data which natively have different access densities, so there's different economics for different types of storage. Thus, a blended approach is almost always the most economically viable approach, if you look at it from that perspective. And I would tend to say that there would be a larger percentage of Flash used as that premium tier of storage, maybe in the 10 to 20% range, depending on the customer, but this is so customer dependent that while I agree with that analysis from an analytic perspective, I believe the conversation and the questions you should ask should be more around what needs to be fast and how fast does it need to be. Because often if you're just looking at the distribution based on a capacity metric, you're ignoring the business value of, yes, well, you can see performance improvements across your entire infrastructure, but what does it mean to this revenue generating application if this one's 4 times faster? That sort of thought process isn't reflected in an I/O distribution curve and really needs to be thought about when you're considering your storage choices. Vendors like to talk about massive IOPS and massive bandwidth, but in reality, is that really the value that the solid-state storage is delivering? Flash, yes, it can get to those massive IOPS and massive bandwidth. We talk about a petabyte of flash in a single rack with 210 gigabytes a second of bandwidth and 18 million IOPS, something like that. But the reality is that most enterprise clients aren't pushing that kind of transactional throughput. And for many clients, the value is all about latency. Here's how I like to frame it. We have bandwidth and IOPS as aggregate performance measurements. So that's things per per second, whereas latency is the speed of each of those individual things. And so in the case that you aren't filling the pipe like you described, like most clients actually, then the latency actually is the most important factor of the overall performance, because it's the speed at which each individual thing gets done. And the only way you get better latency is by improving the hardware. It's not about the software stack so much, it's about that core hardware performance, because you can only get data in and out as fast as your hardware will let you. And that ultimately leads to a nice conversation about the value of flash system as that pure hardware piece, the performance engine.